In this video, we're going to look at how do we solve equations using complex numbers. So complex numbers enable us to actually find the roots of equations that we haven't been able to find the roots of before. In other words, when the discriminant in a quadratic, for example, was less than 0, remembering that the discriminant is b squared minus 4ac, if that was less than 0, then we couldn't solve it because we had to find its square root and we couldn't find the square root of a negative number. But now we know that we can, because we know that if we want a square root, we know that I squared is equal to -1. So we can actually find the square root of a negative number using that idea. And so we're going to incorporate that plus our understanding of what we call the difference of two squares, which is something that you learnt back in middle school or year 10, where if we multiply a plus b with a minus b, then it becomes a squared minus b squared, so the difference of two squares. So we can use that idea and that expansion or factorising process to solve equations where we've got a sum rather than a difference. And so if we look at the equation z squared plus a squared, we can actually factorise that now. So if we look at z squared plus a squared, then that's going to be equal to, we can change it first of all into a subtraction. So if we make it z squared minus, well, what we can do is we can incorporate an I, because we know that I squared is equal to -1. So therefore, if we have minus I squared, so negative I squared is equal to +1. So we could create a negative sign. So we're going to rewrite that as the difference of two squares. And so that then becomes z plus ai, z minus ai. And therefore we can actually find the roots. So if we let that equal 0, which that equation is equal to 0, then we can say that therefore z is equal to ai, or plus or minus in this case, plus or minus ai. And that would be our roots. So let's have a look at some numerical examples. So z squared plus 16 equals 0. So I want to solve for z. So first of all, we need to factorise. So we're going to go z squared plus 16 equals 0. So we'll write that as a subtraction. So z squared minus 16i squared. Whoops, I should get rid of that bracket. Sorry about that. So first of all, we're going to introduce our I squared and make it a negative. And so we'll write that as two squares now. So 16 is 4 squared. And so, of course, my pen stops working, doesn't it? There we go, back now. So we're going to have 4i all squared equals 0. So we're going to have z plus 4i, z minus 4i equals 0. And because that's equal to 0, the Null Factor Law says that z is going to be equal to plus or minus 4i. Now, we could have solved that one straight away, okay, and we can do the same thing with the next one. Because it's a very simple quadratic, we don't have a b term, so we can actually solve it in a similar way if we're careful. So we'll do the second one a different way. So we've got 2z squared plus 6 equals 0. So again, this is a quadratic without a middle term, the b term if you like. So I can actually just rearrange it. So I'm going to go 2z squared is equal to -6. So z squared is going to be equal to -3. So from there, what I can do is say, all right, well, z squared is -3. So z is going to be this plus or minus the square root of -3. Whoops. Okay. And so I know that that's going to be plus or minus the square root of 3 multiplied by the square root of -1. So it's going to be plus or minus square root 3i. So I can solve it that way as well. So there's two ways of doing it. Now, why did I show you difference of two squares if you can solve it as simply as that? Because we're going to be using the idea of difference of two squares if we have to solve a more complicated quadratic function, just like we've got up the top here. Okay. So if we're going to solve the equation 3z squared plus 5z plus 3 equals 0. Now, if we're asked to solve it, then we can solve that a number of ways. And so the way we're going to do it is, well, we can use a quadratic formula. So I'm going to do that first of all. So we know that the quadratic formula, because our variable is z, is going to be minus b plus or minus the square root of b squared minus 4ac all divided by 2a. So we know that's a, that's b, that's c. So we're going to have negative 5 plus or minus the square root of 25 minus 4 times 3 times 3, all divided by 6. So negative 5 plus or minus, so 25 minus, or 4 3s are 12, 3s are 36. So 25 minus 36 is negative 11. So at the square root of negative 11. Just make sure I've got that right. 25 minus 36, yep. Okay, all divided by 6. Okay, and so that's going to be negative 5 plus or minus square root of 11i over 6. And that's my roots. And that's how you can solve it. And it's as simple as that. And we can actually find the roots then. In a future lesson, we're going to learn, well, what does that even mean? What do those numbers mean? But for the moment, let's just worry about the problem. So we can do it that way. Or alternatively, we could complete the square and solve it that way. And the completing the square is something that you learnt back in methods. And we're going to remind ourselves how to do that here. So in order to do that, we're going to scroll down and we're going to do a bit of a simpler one first. Let's get rid of that big yellow line. So let's do question A first, and then we're going to do B, and then you're going to go back and have a go at that one and see if you can get the same solution. So let's look at A first. So first of all, this one just asks us to factorise, but I will solve it to show you how to do it. It's not hard, but the first thing we do is we're going to factorise. So if you remember to complete the square, well, the process to complete the square, it's all about the middle term here, this term here. Well, in this case, it's equal to 1. So in this case, b equals 1. Okay, so we don't have any coefficients, so we're going to make it a bit simple. So we're going to go plus z. And then to find out what we have to add and subtract, we have to halve b and then square it. So half of b is a half, and the square of that is a quarter. So we're going to add a quarter onto there. Okay. Then we're going to minus a quarter, and then we're going to add 3, which is to carry down the constant. Okay, so now we can complete the square. So we're going to look at this part of it here. So this is my square term, so it's going to be z plus a half squared. Okay, so that's the first part, the bit in the blue brackets. And then minus a quarter plus 3 is 2 3/4. So 2 3/4 is 2 3 7. No, 2 3/4. My brain isn't working at the moment. 2 4s are 8, 3 is 11 on 4. So plus 11 on 4. Okay. So there I've completed the square. Okay, so if I want to solve it, I want to let the z squared plus z plus 3 equal 0. So I've got 0 equals z plus a half squared plus 11 on 4. So minus 11 on 4 is my first thing that I do, equals z plus a half squared. Then I take the square root of both sides. So I'm going to have plus or minus, and this is the key you have to remember. When you take it from a squared to a singular term, you have to take plus or minus negative 11 on 4 equals z plus a half. Okay, and so I'll simplify that now before finishing it off. So I'm going to have plus or minus the square root of, oh no, actually, so the square root of negative 11 is going to be the square root of 11i. The square root of 4 is 2. And so therefore, to rearrange that, I'm just going to swap the sides. So the positive a half moving to the other side of the equation will become negative a half plus or minus square root of 11 on 2i. And there's my roots. There's 2 roots there, so therefore z is equal to minus a half plus root 11 on 2, or z equals minus a half minus, oh, forgot the I, 11 on 2i. So there are my two roots. And that's how you can solve it using complete the square. I can, if that's how to factorize. So the factorized part, so this here is the factorized answer. No, it's not. We haven't factorized it. I've solved it. So now we're going to factorize it. So we're going to come across here and we're going to factorize this thing. Okay, so how do we factorize? So I've got z plus a half squared plus 11 on 4. Okay, so what we're going to create is the difference of two squares. Okay, so keep in mind, this is the factorizing part. Okay, so first of all, I've completed the square. I went down this, so going down this path is solving it. Okay, working out how to find the roots. Now I'm going to go down the factorise path. So to factorise it is what we did earlier. So I'm going to write it as the difference of two squares. Okay, so what I need to do here is say, all right, I need to, so that it's the square root of 11 over 4 times I squared. Now it's the square root of 11 on 4 squared. I haven't given myself enough room here, so I'm just going to write that again. So it's going to be the square root of 11 on 4 squared, which gives me 11 on 4, times I squared. And so therefore, I'll just write that in the next line. So z plus a half squared, so that's my a if you like, minus root 11 on 2i all squared. Okay, because the square root of 11 is root 11, the square root of 4 is 2. And so now I've got my difference of two squares. So we're going to write our difference of two squares. So the first term, so it's a minus b, or a plus b, a minus b. So the a is z and a half, plus b is root 11 on 2i. And then it's going to be a, which is z plus a half, minus root 11 on 2i. So if you like to think of it like this, that's a plus b, a minus b. And they're my factors. Okay, and so we can go, again, if you want to use the null factor law, we can say, well, the null factor law is z plus a half plus root 11 on 2i equals 0. And so we can rearrange and to get z by itself to move everything on the side, minus a half minus root 11 on 2i. And then z plus a half minus root 11 on 2i equals 0. So again, move everything to the other side. So it becomes minus a half plus root 11 on 2i. And we get our factors. Okay, so what I'd like you to have a go at is trying to do the other two. Now notice this one's got a coefficient. So this one's going to be a little bit more tricky in terms of completing the square, but you've done plenty of those in methods, so you shouldn't have too much of a problem. But what I'd like you to do is to then practice the factorising. Okay, and what we'll do, and then you can go back and have a go at this guy. All right, so there's two questions to try where you're completing the square and then factorising. And in the top one, you're completing the square to solve. Once you've done those, there are some questions in exercise 15D for you to have a go at. All right, good luck.